Hi. Today we'll be talking about forms of linear equations. You're probably familiar by now with the standard equation for a line y equals mx plus b. There are other forms of linear equations or lines that you might see which are helpful for finding different things. And today we'll go over what they are, how they're represented, and when you want to use each. When each might be beneficial to you. So we'll start off with slope-intercept form. Y equals mx plus b is a general form that we write it, where y refers to the y value, x refers to the x value, b refers to the y-intercept, or the point at which the line touches the y-axis, and m refers to the slope, or the rate of change, right? So if I was given, say, a y-axis point in a slope, I could very, very easily write the equation for this line. This is probably the most common form that you'll see a line represented just because it's so easy and pretty universal to find, right? Let's say I know, I have a slope of 5 and I have a y-intercept of -1. Well, then I know instantly my line is y equals 5x minus 1, right? Which I can graph really easily and be really on my way. Of course, this is a rough estimate, but this also works. Works even if I don't know the y-intercept. If, say, I'm given 2 points, let's say 2, 3, and 4, 5, I can very quickly find the slope. The slope is rise over run. So 5 minus 3 over 4 minus 2, which is 2 over 2, or 1. So the slope is 1. And then I can substitute in one x value and one y value to find the y-intercept. So I could substitute 3 in for my y and 2 in for my x. I find that my b is 1, so my full equation is y equals x plus 1, which would look something like this. And now, you notice we did have to go through a little extra step when doing that, when we weren't presented with the y-intercept. We had to take 2 points, we had to find their slope, and then we had to plug a set of points in to find the y-intercept. Well, there's a type of form of this line that kind of resolves all that, where you don't need to find the y-intercept. You just need to find the slope and a single point on that line. That is called the point-slope form. So y minus y1 equals m times x minus x1. I'd be saying, what are y1 and x1? Well, x1 and y1 are just refer to a single point on a line, right? Where y and x are every point on the line, right? So you just need to know a single point on the line and the slope m, and you can write an equation for that line, and then you can go ahead and you can graph it, because we'll have a system where you can find out what values you need to plug in, and you can start graphing, right? So let's say I know the point 2, 3 is on the line, 2, 3. And I know I have a slope of 2, so that means I'm going to be going up 2 over 1, up 2 over 1. Boom. I can instantly graph my linear equation without having to find the y-intercept, without having to plug my point back in to the equation, do some algebra. I instantly have all I need to graph the equation, and all I need to do to represent my line as an equation. And that's point-slope form. The last common form you'll see is called standard form. And standard form isn't the most fun. It looks like this. ax plus by equals c. And a, b, and c are all real standard numbers, preferably integers. They cannot be 0. So if you're given an equation and asked to make it in standard form, you want to make sure you get all your x's and y's on one side and keep your c's keep your standard integers on another side. And make sure that the coefficients of those, the a and their b, are integers, not fractions. You can't have fractions. So, and that's the standard form. But why do we want to use it? Say we're, given this form and we're asked to find the x or y intercept of a line. In that case, we don't need to convert this into any other form. It's actually, this is the best form for finding x and y intercepts. So all we have to do is plug in 0 and solve, right? Say I want to find the x-intercept of 5x plus 2y equals 1. The x-intercept. That's where the point on which the graph touches the x-axis, or where y is 0. So I can instantly find that by just plugging in 0 for y, and then I have 5x plus 2 times 0 equals 1, or 5x equals 1, so x equals 1/5. So when x is 1/5, at the point 1/5, 0, I touch the x-axis. And that's where the standard form shines, finding your x and y intercepts. Other than that, it's usually more useful to take this and convert it into a different form, or to just write the equation as a different form to start with if you're given like slopes or other values. So how do you do that? Well, if you wanted to write this as a slope-intercept form, we want to get the y by itself. So we start by subtracting ax. Then we want to get rid of this b because we want y all by itself, so we divide by b. We end up having negative ax over b plus c over b. And we've thus converted what we were given in standard form to slope-intercept form. If we wanted to convert it into point-slope form, we take the slope that we've collected here, and then we just find a point on that line. Sometimes it's given to us. Sometimes we can just plug in what's x, what's the point where x is 1, find that point, and then write point-slope form. So those are the 3 forms of linear equations, and each of those have a specific purpose and can help you achieve a specific goal. Know when to use them, and your graphing and algebra solving days will be a lot easier. I hope you enjoy, and I hope you have a great day.